Welcome to my channel Phi Concepts CHF. This is the second part of the logic family series where we are going to study about TTL NAND gate and TTL NOR gate. TTL NAND gate, this is the circuit diagram. There is a multi-emitter input transistor T1. So this is a multi-emitter transistor. Each emitter acts like a diode. T1 and R1 resistor, this is the resistor R1 and T1, they act like an AND gate. The rest of the circuit just inverts the signal and hence acts as a two-input NAND gate. The output transistor T3 and T4 form a totem pole, that is either upper or the lower transistor is on. When T3 is on, then the output is high. But when T4 is on, the output is low. This is the output Y. This gives the concept of the multi-input emitter transistor. For this, if any input is low, you can see that the two inputs A and B are applied to the two emitters of the transistor. If any input is low, the corresponding base emitter junction becomes forward biased and the transistor conducts. We will see the first case, if A and B are both low, either A or B is low. So we are taking the first three input combinations. Then what will happen is that the emitter diodes will conduct. So we are applying in low inputs to A and B. Then this base emitter junction diode will be forward biased and T1 will become on. And because of that, its collector voltage of T1 will go low, which will switch off T2. As T2 is off, T4 will also be off. And hence the output Y is high. Now consider the input combination where both A and B are high. When both A and B are high, this base emitter junction diode, it will be reverse biased. So when it is reverse biased, T1 will become off. When T1 is off, the collector voltage of T1 goes high. So this collector, it goes high and this will switch on T2. Okay, so T2 will be on. When T2 is on, T4 will also become on and hence the output Y, the collector voltage of T4 will go low and hence the output will go low. Next is TTL NOR gate. This is the circuit diagram. This is the truth table for NOR gate. In this circuit, this is the NAND gate circuit only. Only the transistors T5 and T6 are added. T5 and T6. We'll see the first input combination or the first case, that is this case where A and B both are low. When both are low, the emitter diodes of both T1 and T5, they will be forward biased and T1 and T5 will then conduct. When they will conduct, their collector voltage will be low and that's why it will cut off T2 and T6 transistors. This is T2 and T6 transistor. Now as T2 is off, T4 will also be off, and as T4 is off, its collector voltage will be high and therefore the output Y is high. Second case, if A and B both are high, or we will consider that A or B, either A or B is high. The emitter diodes will stop conducting if the inputs are high. T1 and T5 transistors, they become off, and T2 and T6 will then become on because the collector voltages of T1 and T5 will be high. So T2 and T6 will be on. T3 will then become off, while T4 is on. So as T2 is on, from here we see T2 goes into conduction, so T4 will become on, okay, as T2 and T4 are connected. So as T4 is on, its collector voltage will drop and hence this output Y will be low. Thank you for watching this video.